basically, in order for me to do these more complicated question with high radical values, you have to have an understanding of this concept, which is when we are taking the square root of 9, I'll find a number. When I square it, I get 9. And the answer to that is 3, right? And we have to remember that there's different ways of writing square root 9. We could say the exponent on the 9 is an exponent of 1. And when there's no number in front of this radical sign, it implies that there is a 2. Okay, so 2 is like the automatic default for square root. And if you look at your calculator, you can see that's consistent, right? You have the square root button and you have the cube root button, but then we noticed that for the cube root, we actually had to write the 3. But with the square root, we never really asked ourselves, but we have that button, and it implies that over here, it's actually a 2, okay? And keeping that in mind, it might be helpful sometimes to write that radical part as an exponent in fraction form. So that's just like a side note so that we understand kind of what's going on with this. And it's in case we get to more complicated situations. So it says the exponent on the number becomes or is the numerator of the exponent. So that, and then when it is being square rooted or cube rooted, that number on the root becomes the denominator. So yeah, when you have 6 square root of 2 squared, it's more helpful to think of it like 2 to the exponent to the 6. That way you can simplify the fraction involved in the exponent. So that concept and another concept is kind of what we need for question unit. You need to use prime factorization when you're actually doing some of these questions. So what I did was, okay, when I look at this, when I see 6 root of 3, I can't do much with it because the 3 is a prime number. I can't really break it down, but just as a side note, I wrote that 6 root of 3 can be written like that. 3 to the exponent 1 over 6. So on the side, I did the prime factorization of 192, and we kind of did that before at the very beginning of Unit 3, I believe. And so I rewrote what that is. So it's 192 to 2 to the 6 times 3. So what I'm doing from in the first step is I'm breaking it apart that way. And so I have -3, 6 root of 3 minus 2, 6 root of 2, 6. And then I'm copying and pasting all of this in blue and all of this in green. The benefit of doing that is because remember how I can write my radical sign as an exponent fraction? And so I can actually write this part right here as 2 to the exponent 6 over 6, and over here as that as well. And so in that case, I could simplify that. So 6 over 6 is 1. So that means that's 1. Remember when you multiply powers of the same base, that's 2 to the 1 times 2 to the 1, which is 2 to the 2. And so I simplify that set. And then 2 to the squared is 4. And so I have all of that. And then I'm noticing that there are like terms. So these are like terms. And so I'm collecting those. And I have to make sure that when I am collecting it, that the radicals that I'm combining have the same radical sign. So it's both 6 root of 3. And then I just add the coefficients. And so that is my final solution for 8.